Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Maybe you figured this out, Houston, but the problems can get more complex when we start talking about circuits and resistors. And so today we want to talk about what are called combination problems. These are ones where you have, well, both series and parallel in junction. So let's do this example. Let me sketch it out here. So the question you might ask is, what is the, as it says, the total resistance and then the current through this system? Notice you've got, these are in parallel. This series, this is in parallel with this, but this has two different resistors. The way to do this, folks, is to do all the series pieces first and then play the parallel circuit game. Because if you remember, in a series circuit, the R total is equal to R1 plus R2, etc. And we've got R1 and R2. So really, what's the resistance of this piece? It's going to be 900 ohms, right? And so now if I want to find the resistance, I can say 1 over R total, I'm trying to find this, would be equal to 1 over 450 plus 1 over 900. On my calculator, I'm going to just literally type 1 divided by 450 plus 1 divided by 900. It knows kind of order of operations, so that's, you don't have to like put parentheses and junk like that. And I get 0.0033333. But I'm just going to take that, remember, because that's 1 over RT, take it to the -1 power, so caret -1, and I get R total to be 300 ohms. So that is the total resistance. So what's the current in this system? The total current, V, equals IR, and the current, if you will, is equal to I, and that's where current I doesn't make sense, does it? Equals V over R, which is 24 volts, divided by the resistance, which was 300 ohms, and that will give me the current of 0.040 amps. The problems will be more difficult, and we're going to play around with even more complex ones, but it's going to be something where you're going to need to work on that with my direction and help. Eventually you're going to get the idea, but the simple idea is just to add the ones in series and then pretend everything's in parallel. And they can get more complex. I could put one in here. I mean, there's a lot of different things. Like if I put another one in here, you know, I would find out what this resistance is right here as one parallel circuit. That would be 300, and if this was another 200, then it'd be 300 plus 200 would be 500 or something like that. And you'd figure this out, and we're going to play that game once we get working on these problems in class. So Houston, we don't have a problem. And a note, if you're in the 2020 class, this is the last video of the year. Isn't that crazy? Is that crazy? You guys have been an amazing group, and I have so appreciated being your teacher this year. I know it's been such a weird year being the COVID year, but and I love you guys. We'll see you in class.